solving absolute value equations. We gotta know what absolute value means, first of all. Yeah. Does anybody have a idea of what absolute value means? Heard about it before? Devontae? How about you, Cody? You had a hand or two.
The total value?
Not, it's not like a total, but it's, okay, first of all, let's talk about the symbolism for absolute value, and I need you really engaged here, because it's really important that we understand the difference between when we see two little vertical line segments on either side of something. Notice they're not brackets, they're not parentheses, they're not curved, they're just a vertical line segment and another vertical line segment, and they will be around something. That right there means you say absolute value of. That's what they stand for. So first of all, we have to make sure we recognize the symbols that tell us we're looking for the absolute value of something. And the absolute value actually means it's distance from 0 on the number line. So how far is that? Whatever's inside those absolute value bars, how far is it from 0 on the number line? Okay, now let's keep in mind that distance, when you think about the distance of something, do we measure that in positive and negative numbers? Or do we just keep it to like positive numbers and 0 maybe? Can we have 0 distance? And you just not go anywhere, just stand still and not cover any distance? Okay.
It was off that time, so one day we don't even lock it in.
That's exactly what we're going to do. And when I walk towards Devontae, is that positive distance? Or did I just cover some positive distance?
Yes.
Yeah, okay. If I walk backward, so I can keep an eye on y'all. If I walk backwards, do you now say I walk negative distance? No, we don't talk about distance ever as negative. So when we talk about distance, we either talk about there's no distance at all, or it's positive distance. We don't talk about negative distance. So let's keep that in mind too. So when we have those absolute value bars around x, and it is set equal to 2, we have an absolute value equation. The absolute value of x equals 2. That's what that reads. This is really asking which numbers can x be, what can we put in there for x, that are 2 units from 0, because remember absolute value means distance. So we're asking what numbers can we put in here for x that would have a distance of 2 from 0 on the number line. There happen to be 2 numbers that do have a distance of 2 from 0. What are they? 2 and?
-2.
Negative 2. 2 and negative 2. They're both 2 units of distance away from 0. Negative 2 is 2 units to the left of 0, but it's still a distance of 2. We don't talk about distance as negative. And we have positive 2 on the other side of 0. It's 2 units to the right of 0. So we say that the solution to that absolute value equation, we have 2 solutions. We have x equals 2 and negative 2. There are 2 solutions for that equation. Okay? So the solution for the absolute value of x equals 2 and negative 2. Okay, let's do some practice then. Let's solve the equation. The absolute value of x equals 7. What's that asking?
It's asking to find x.
It's asking us to find x. It's saying find what x can be, but how are we going to find that? What else do we have to ask? Cody?
What is the absolute value of x?
Okay, and what does that mean? What are we really asking ourselves when we say what is the absolute value of x? What are we looking for? Cody?
What is the distance? What is x's distance from 0?
Well, we gotta have some sort of distance. What distance?
The number of distance.
Specifically, look at number 1. It says the absolute value of x is 7, equals 7. So what it's saying is, what number or numbers can you put in there for x that have a distance of what?
7.
7. So do we know any numbers that have a distance of 7 on the number line from 0? That's what we always talk about, distance from 0 gets to be the, like, here I sit, you figure out how far you are from me. So are there any numbers that have a distance of 7 from 0? What are they? What numbers actually on the number line? Let's look at the number line up here. What numbers are actually 7 units away from 0? 7. 7 is 1, 2, 3, 4, 5, 6, 7. It's 7 units of distance from 0. What else? Any others? How about -7? -7 over here is 1, 2, 3, 4, 5, 6, 7 units from 0 also. Are there any other numbers that are exactly 7 units from 0? No. So we're going to drop our absolute value bars and say x can be, we can substitute in for that 7 and -7.
What is the last thing you wrote there?
Okay, you do number 2 now then. You solve number 2. It says the absolute value of x equals 12. Okay, who's going to share with me what the solutions are? Or solution, whatever. I don't know if it has one or more, but Jossie? Okay, so x can equal 12 and x can equal -12. Because if we put those back in for x and we say, how far is 12 from 0 on the number line, we'd say, oh, it's 12. If we put -12 in there for x, we would say, how far is that from 0 on the number line? We'd say it is also 12 units away. Okay? How about number 3? The absolute value of x equals 0. Are there any solutions for this one?
Yes.
Are there any numbers that are 0 units away from 0? Uh-huh.
Well, there's one.
What is it?
0.
0 itself. 0 is 0 units away from itself, isn't it? 0 is 0 units away from itself. In other words, it's kind of like it's right there. So we would actually say that the only solution for this one is 0 because it's the only number that has no distance from 0 itself. Okay, let's look at number 4. The absolute value of x equals -5. Or in other words, it's asking you this: what number or numbers can x be that have a -5 distance? What number or numbers have a distance of -5 from 0? -5 and 5? So if I asked you how far away 5 is from 0, you would say it's a -5 units away?
It's just
Okay, well, how about if I said to you, if I asked you how far -5 is from 0, what would you say? Would you say it's a -5 units away?
Yes.
I thought we just talked about that if I took backward steps away, we don't count that as a negative distance. We don't say -5 steps. We say she took 5 steps. Yeah, she was going backwards, but we don't talk about distance as negative. You don't back down the road in your car and say, well, I went a -2 miles. Whatever amount of distance you cover, you just talk about it in a positive manner. Or if you don't cover any distance, you say, I didn't go anywhere, 0. So we have to say for this one, number 4, there is no solution. If we are asking for negative distance like this one is, there isn't such a thing as negative distance. So we're going to put that no solution because there is not negative distance. We're going to be tempted to think we could say it's 5 and -5, but no. 5 and negative 5 have a distance of 5, not a distance of negative 5. Okay, so those are all, notice every one of those had just x all by itself inside the absolute value bars. And it was an easy process. We could just say to ourselves, what number or numbers have that distance on the other side? And those were our solution or solutions, or maybe no solution. Well, notice what's happening here next. We have the absolute value of x plus 3, that is set equal to 5. So this time it's not just asking what can x be that has a distance of 5. It's saying which numbers can x plus 3 be? Which numbers can x plus 3 be that are 5 units from 0? Okay. So first of all, we got to decide which numbers are actually 5 units away from 0. What numbers are actually 5 units away from 0? 5 and negative 5. Yeah, 5 and negative 5 are. So here's what we have to do. We have to say, okay, well then that x plus 3 that we're trying to figure out what it can be, we're saying it has to be 5 units away, and we could also set it equal to the negative 5 because the negative 5 is 5 units away. So our x plus 3 can become a positive 5 or it can become a negative 5 because those are the two numbers that are actually 5 units away from 0. So notice our absolute value bars aren't there anymore. We dropped them and we set up what we call cases. There are 2 cases here, and now we have one-step equations to solve. What do we do to get x alone? In both cases, what do we have to do?
Subtract from both sides.
Subtract 3 from both sides. So we'll subtract 3 from both sides over in this one, and we will get x equals what? What do we get? 2. So there's one of our solutions. And then this one has the same, x is being added to 3, so we do the same thing, subtract 3 to get x alone. And we end up with x equals what? Negative 8. So this time our solutions are 5 and negative 5 because we have that 3 being added to the x. So we have to find what are the things that if we put them in there for x and add 3 to them and calculate its distance, it would be 5 units from 0. So we're going to do check problems, okay? And you have very few problems of homework to do, so you have to do check problems on these ones when x isn't by itself, okay? So we're going to write down our equation, the absolute value of x. Oh, by the way, make sure you make, tall enough x absolute value bars so they don't look like ones. You might mistake them for a 1. Have them touch the top line and have them touch the lines above and below in that space you're in. So here's our equation. We're going to write it twice because we have 2 solutions to check. Notice it didn't change to negative 5 over there. It's the same equation that we started with. We're just doing a check problem. We're not solving, we're checking our solutions. So now what we'll do is our absolute value bars are still there. We'll substitute in, oops, I didn't do the substitution there, sorry. We'll substitute in for x, our 2. We'll add 3 to it. That's all we're doing in that step. We substitute 2 in for x. Now let's put the 2 and the 3 together inside those bars. What do we have? 2 plus 3 is? 5. So we have the absolute value of 5. Now we ask ourselves, what is the absolute value of 5? Or in other words, how far is 5 from 0 on the number line? 5 units away. So to get rid of the absolute value bars, we give its distance. Its distance is 5. The other side is 5. It checks out. Same process again. Substitute our other solution in for x. So negative 8 goes in for x. What is negative 8 plus 3? Negative 5, so it's going to be the absolute value of negative 5 next. And now we want to find the absolute value of negative 5. What is the absolute value of negative 5? How far is negative 5 from 0? 5. It has a distance of 5. Bring down our other side, and that one checks out also. Now, if we had not solved that correctly, we made a mistake. When we substitute it back in, it should not have checked out. So let's just say for some crazy reason you decided that negative 5 over up here when we were solving up here. Let's just say you made a mistake right there. You said negative 5 take away 3 is negative 2. Let's just pretend you make that mistake, okay? So you got negative 2 is the other solution. So you got x equals 2, and then you said that the other solution was negative 2. When we substitute negative 2 in, let's see what would happen. What's negative 2 instead of negative 8 plus 3? What is negative 2 plus 3? 1. So we would have the absolute value of 1. How far is 1 from 0? 1 unit away. We would have ended up with 1 equals 5. Is that true? No, it would not have checked out. Yes, Jessie?
For on the right side, we put negative 8 plus 3 equals 5. Isn't it negative 5?
Nope, because what we're doing is we're just substituting into the original equation. So here's the original equation, right? We substituted in what we say our x is, and that so this doesn't change. The equals 5 stays equals 5. It doesn't change, just like that plus 3 didn't change. So now we substitute in what we think is a solution, and we say, what is negative 8 plus 3? The absolute value bars are still there. We say negative 8 plus 3 is negative 5. We just bring down the other side of the equation. We keep bringing that down because there's nothing.
I'm just trying to figure out how it became 5, and at the top it says x plus 3 equals negative 5.
Because, up here, when we were doing our step of work right here, because to be able to find the solution, we have to take whatever is inside the absolute value bars, and we have to set it equal to any number or numbers that have a distance of 5. So that helps us solve it. So we're saying, okay, x plus 3 can be set equal to 5, because 5 has a distance of 5. And x plus 3 can be set equal to negative 5, because negative 5 has that distance. So that's when we're solving, we do that. That's how we are able to get rid of the absolute value bars when solving. But then when we're checking, now we don't do that. We just substitute in and keep simplifying until we get it down to our final statement. Okay? Cody?
On the answer, when you're subtracting negative 8 and 3, wouldn't your answer be negative 5 equals 5?
No, because we have to also still do this step here. We have to say, what is the absolute value of negative 5? And when you ask that question, you're really asking, what is my distance from 0? Its distance from 0 is 5. So we're continuing to simplify. Kind of think of it like this, class. When you still have absolute value bars around something, and there's a value in there, there's a constant in there, it can still be simplified. Just like 3 over 6 can still be simplified. You're not going to find 3 over 6 in an answer bank. What are you going to find instead? 1/2. So think of it as you're simplifying, okay? So we substitute in, and then we're kind of like simplifying, getting it down to what we can't do anything else anymore. All good questions. Anything else? Still confusing at the moment. This is confusing stuff. I'll give you that. Okay, let's go to the back and see what I have for us to practice back there. Okay, there's one of them like we just did, where the x is not by itself, it has something happening with it. inside the absolute value bars, okay? So, first thing we look at is we say, okay, we need to set x minus 4 equal to any number or numbers that have a distance of 9, because there's a 9 on the other side. So we need to set x minus 4 equal to any number or numbers with a distance of 9. Okay, do we have any numbers that have a distance of 9? Are there any numbers on the number line that have a distance of 9, Josie? 9 and negative 9. So we're going to ditch those absolute value bars, and we're going to set up two cases. We can set x minus 4 equal to the 9, and we can set our x minus 4 equal to the negative 9, the two numbers that have a distance of 9. So when we're ditching the absolute value bars, the reason we can is because we said, oh, we found some things that have this distance. So we're going to set it equal to those things. And now we'll just go about solving our two cases. What are we going to do to both sides of the equation? Add 4. So we'll add 4. We'll finish up this one first. We end up with x by itself, and what is x equal to for the first case? It's 9 plus 4. 13, yeah, 13. Okay, so there's a solution. Okay, and then now we'll go over and solve our other case, which we'll do the same step. We'll add 4 to both sides. X ends up by itself. What's negative 9 plus 4? Negative 5. So the other solution is x equals negative 5. So we are now saying those two values would make this equation true. Well, we're going to prove it. We're going to check it out and see if they do. We're going to see how we did. So we're going to write down the equation as it was given to us. We're not solving anymore. We are now checking. So we use the same equation twice. Notice it doesn't become 9 and negative 9, it's just 9 in both of them. We're just checking. So we'll substitute in a 13 for our x. Everything else stays as it is. Absolute value bars are still there. We're subtracting 4. There's a 9 on the other side. So we're not doing the same thing to both sides. We're not solving. We're substituting in, and now we're going to simplify it down until we can't do any more. So we can simplify inside those absolute value bars. What is 13 take away 4? 9. So we say we now have the absolute value of 9 on the left side. Bring down our equal sign, bring down our 9. Absolute value means what again? Distance from 0. So when we see those absolute value bars around 9, we say, okay, I can simplify you some more. What is the distance 9 is from 0? 9. So we ditch the absolute value bars and put its distance there. Bring down the equals 9 and say, checks out, as we get 9 equals 9. True statement. Okay, we have the other one to do. Substitute in a negative 5 this time for x. And again, everything else stays the same. All we're doing is subbing in that negative 5 for x. Okay, now we're going to put that negative 5, take away the 4 inside the absolute value bars together. What is negative 5 take away 4? Negative 9. So we say, okay, that becomes negative 9 inside the absolute value bars. And now we say, I can take the distance. I can find the distance of negative 9. What is negative 9's distance? 9. So we put a 9 here, ditch the absolute value bars because we're saying its distance is 9. We answered the question, and we get equals 9. That one checks out also. Okay, questions about that one? Anything Anything still unclear with that problem? Okay, then let's go on to number 6. Look at number 6. What's going on inside the absolute value bars this time? Something being added or subtracted to x? No, there's a multiplication going on. Do we know how to do multiplication?
Yes.
Yeah. Okay, but then we look at the other side before we even start, and we say, okay, that means 5x can be set equal to any number that has a distance of what?
20.
20. Do we know any numbers that have a distance of 20?
Yes.
What are they?
20 and negative.
Okay, so we're gonna drop those absolute value bars and say 5x can have a distance of, can be set equal to 20 because it has a distance of 20. And 5x can be set equal to negative 20 because negative 20 has a distance of 20. And now we will solve those. So we have 5x. What do we have to do? Divide by 5. So we have to divide both sides by 5. And what's one of our solutions? 4. And then we need to divide by 5 on the other case also. And what are we going to get for our second solution?
Negative 4.
-4. Okay, we're not done with these problems today until we do what?
Check.
Check problem. So we're going to do a check problem now. So write the word check here so you know that's what you're doing. We're going to write down the equation as it's given to us to start with. And we're going to write it down twice because we actually have 2 solutions to check. Same equation, checking the equation we started with. Same equation, but we have 2 different solutions to check in it. So we'll substitute in our first x value here, which says 4. So we're going to say 5 times 4. And 5 times 4 is 20. So now we have the absolute value of 20. And we bring down the rest of our equation. How do we get rid of absolute value bars? What do we say? Finds its distance. What is 20's distance from 0? 20. Yeah, it's 20. So we end up with 20 on the left side. And we have a 20 on the right side. So we're feeling good about that solution. It checks out. Now we go over and do it with our other one. So we have 5 times -4 inside our absolute value bars, and then our equals 20. What is 5 times -4? -20. So we have the absolute value of -20. We have the absolute value bars around something. We're asking for its what? Distance. So how far is -20 from 0? 20 units. And so that solution checks that. We can feel good about our 2 solutions. Okay. Do I have anybody in here work ahead? Have number 7 done, just out of curiosity? No? So tell me something about this one. What do you think, Jossie?
Well, I have negative equals -3, but we can't do that.
Oh, because we can't have what?
Negative distance.
So what do we say? We don't even have to do anything. We have to say it's no solution. Because why?
We can't have negative distance.
Yeah, we're going to write that because can't have negative distance. And it's not gonna hurt us to write all that out because that's all we gotta do. There's no solution, there's nothing to check. Now here's what would happen. Students do this, and you'll catch yourself doing this too. You'll go about solving this, you'll be like, oh, I can set x minus 1 equal to 3, and I can set x minus 1 equal to negative 3. And you'll, merrily solve along, and you'll end up with 4 as one of your solutions. And for the other solution, you will end up with negative 2. Okay, let's try and check those. Let's just do it mental math here. What's 4 take away 1? 3. So we would have the absolute value of 3. I'll just write it down here. We would have the absolute value of 3 set equal to negative 3. What is 3? What is 3's distance from 0? 3. So we would end up with 3 equals negative 3. Is that true? No. The other solution we would have, I said we would end up with, we'd end up with x equals negative 2. Oopsie, but we've already disproved this one. We've already shown that, basically it's not going to check out. But if we put negative 2 in, take 1 away from it, what is negative 2 take away 1?
Negative 3.
That's negative 3. So we'd have the absolute value of negative 3 equals negative 3. Now some of you would be tempted to say, oh, those match. Check. No, the absolute value bars are still there. What is negative 3's distance? 3. We'd end up with that statement again. 3 equals negative 3. True or false? False. So that's why we do check problems, especially in the beginning when we're new at this, because we find out that sometimes we go on and solve it and we think there are solutions and there really aren't. Or you might sometimes you just do something wrong in it. Here's what you don't get to do. You don't get to do check problems and then go back and right away automatically say, well, then there's no solution to this because it didn't check out. You got to go back and make sure, was it set equal to a negative number? That's when you get to say no solution. If it wasn't, then you must have done something wrong in the solving process or maybe even the checking process, okay? Okay, be done.